Okay, our next speaker is Mr. Roy Arends, who's going to talk about the root zone DNSSEC and how it works and what has happened and stuff like that. So we're just going to get a microphone on top of him and see. And of course get the presentation back up.
So my name is Roy Arends. While the system is being set up, I've learned to start a presentation with a joke. So a network engineer, a statistician, and a developer, they go hunting. Right? They see a deer, and the network engineer takes a shot. It's 1 meter to the left. The developer takes a shot. It's 1 meter to the right. And the statistician goes, "We've hit it." Now, if you're not a statistician, you don't get the joke. Okay, I'm just going to start. I'll let the slides catch up later. My name is Roy Arends. I work for ICANN. I've done a few things in DNS and DNSSEC. And what ICANN is currently doing is we're trying to roll the KSK. Now, if you are an operator of a resolver, could you please stand up? Or if you're responsible for resolver operations. Perfect, I've got a few people standing up. Now, please keep standing, just for a second. Whom of you does validation? If you don't do validation, sit down, please. Brilliant, you guys do validation, perfect. I actually want a round of applause, but we can do that later. You can sit down now, thank you so much. If you run a validator like you guys do, next year is going to be significant. We're going to change the KSK. Now, what is the KSK? In the KSK of the root zone. A KSK is a key signing key. It's basically the trust anchor, the root of the DNSSEC, root of the DNS tree. To give you an analogy, and I'm just shooting from the hip here while the slides are getting up. To give you an analogy, I just want to highlight how important this key is. Now, an analogy there's an analogy with PGP, for instance. Okay, whom of you know Patrick Volstrom? Okay, Patrick doesn't know Patrick Volstrom. Okay, so if you want to have secure communication with Patrick and you want to sign your encrypt an email to him, you need his PGP key. If Patrick decides to change his PGP key, then everyone around him needs to have that new PGP key in order for him to read the new messages. Right? This is how important this is. So we're here at the top of the DNS tree. All the validating resolvers have this one key configured, the one key that we generated in 2010, and that's the key we're going to change next year. So I'm just going to check on these guys. How are we doing with the slides?
The slides are fine, the projector is not.
Oh, okay. Great. So, and by the way, I'm the guy between you and lunch right now. So, anyway, so I actually do need my slides. So I'm thinking of getting. You getting there?
Yep.
Oh, brilliant.
Okay, so they'll switch it on back on and off. Hang on, sorry, hang on. I think they're rebooting the delay.
Wow, this is actually more exciting than my presentation.
This is technology.
Yeah, yeah. This is real world stuff. No worries. So what I'm going to do is I'm going to get my slides, so at least I can see them, even though you can't. And so I can start giving my presentation. Yeah, that's a good point. So the slides are actually online. If you go to your browser and you go to today's page, which is the bottom half of the Netnod Autumn Meeting page, if you type in Netnod Autumn Meeting in Google, you will go immediately to that page. It's your first link. And then hopefully my slides are online, at least. And if so, you can click on it and I'll just start talking. Okay. DNSSEC in the root zone. So the key set is managed by VeriSign and ICANN. And until a couple of days ago, we had NTIA in there as well, but they are now out of the picture for any changes to the root zone. VeriSign manages the ZSK, ICANN as a IANA functions operator, we manage the KSK. One of the questions that we often get is, why change the root zone KSK? Why do it? I mean, it works. There's a few good bits in there, so why change it, right? Now, it's not good crypto to keep a key alive forever. When you generate your PGP key, you have to type in an expiration date. There's no other way around it. When you use SSH and you restart the server, and you all know this, right? If you restart the server, your server will generate a new key. This is how that works. Even browser certificates, how lame they sometimes can be, they have an expiration date. So it makes good crypto sense to have that for DNSSEC keys as well. So, shall I just give the presentation without slide, guys?
Or we connect your computer to the.
Yes, let's connect my
we can
computer.
do that, actually. Other side, I suppose.
Can I put my laptop over there? So yeah, like I said, it makes good crypto sense to have an expiration date. So not sure how this works. So I turned Wi-Fi off for those jokers who started jabbering me in a minute. Anyway, I'll just work from this.
Yep.
So I don't need a clicker, which is great. I can just use the keyboard. No key should stay alive forever. Also, when we did this thing in 2010, when we started doing DNSSEC in the root zone, we wrote this document called the DNSSEC Policy and Practice Statement. And in that document, we said something like, we are going to change this key in about 5 years. Okay, it's a little bit later now, but we are going to change that. Another thing, another reason why we want to do this now, we want to do this while we can, not when we have to, right? So currently, the key set is getting slightly bigger. VeriSign increased the ZSK to 2K bits, right? But we want to do this now, basically, while there is no real pressure to do this. When you need to do this under pressure, or when there's an emergency key rule necessary, there's a potential to make mistakes. So this is the main reason we want to do this now. Here's another problem. We actually don't know. Okay, I do know now in this room who's validating, but we don't know who's validating, who in the world is validating, right? We can't just look at traffic and say, oh, these guys are validating and these guys are not. We can see in individual queries if you have the DNSSEC OK bit set, but it doesn't mean you're validating. So we can't see who's validating. And in a sense, that's kind of a good thing, isn't it? Because if we do know who's validating, we also know who's not validating. And if we know who's not validating, that's an attack vector in itself. So it's not necessarily a bad thing that we can't see who's validating or not. However, since there are countless and uncountable people or validating resolvers out there, we can't reach everyone individually because we don't know who you are. Also, we can't just cook this thing up in a lab environment. I recently did a study. 97% of all queries to the root are bogus, right? So if and this is because there's an enormous amount of, how to say this nicely, optimizable systems out there that still need to be optimized, and still need to be perform better. So if I want to mimic all of that in a lab environment, that just doesn't scale. So we came up with a plan. We actually came up with 5 plans. Number 1 is the operational implementation plan. To me, that's the most important one. That basically says what we're going to do, when we're going to do it, and how we're going to do it. Then we have the systems test plan. That's basically to just fire up the internal system, see if everything works. That's the, it needs to generate a KSK, etc., the HSM, all that good stuff. We have a monitoring plan. We think that by looking at traffic, right, if something goes wrong, like for instance in 2011 we had rollover and die, which is a specific incident related to changing a KSK, we think we can look at the behavior of traffic to see if something is going wrong or not. The external test plan for those developers out there that want to test their own code, their own systems, etc., they can hook their systems up to our external test environment. And then we have also an important plan, which is the backout plan. If the shit hits the fan, excuse my French, right, you want to stop doing what you're doing. You want to go back, or you want to go forward, or you know stuff is going to be bad when you go into the next phase, right? That's what we call a backout plan. That's also a significant plan, and I'll talk about it in a second. All these documents, by the way, are available at this link. Communications approach, that's me now talking to you about this stuff. With some broader communications as well. We also, when we do things, we will use things like Twitter, talk to all the relevant channels, IETF, DNS operations, the right meeting, APNIC, all of those have email lists, etc., where we are going to be involved in. This is basically, this slide shows you what the role is like. We're going to start with the creation of the key signing key. This happens at a, how do you call that? At a key ceremony. We have 4 key ceremonies every year for every quarter. And that key ceremony generates, that key ceremony normally generates the signatures of the ZSK for the next quarter. Remember that VeriSign rolls their key every 3 months, so 4 times a year. This is what a key ceremony is normally for. But what we don't want to do is just step into one of these high secure facilities, fiddle around, generate a new key and tell everyone that, yeah, we're ready. We want to use the same facility and the same processes as we do with a normal key rollover ceremony. So we're going to generate the new KSK, and we're going to do that very, very soon. The next slide will have some dates, so I'm not going to say this now. We're going to do this very soon, this month actually. Then we need to replicate it. Once you generate a key, we also have a secure backup facility. It's not a secure backup facility. It's secure, it's a backup, but it's basically we have 2 places where we have these ceremonies, one on the West Coast and one on the East Coast in the US. So when you generate a key at one site, you need to move it to another site. Now again, we can't just walk into the data center with the keys on a USB stick, stick them in and hope that everything goes all right. Again, we need to do that during a ceremony, right? So you have proper witnesses, proper documentation, and proper processes around this. So that's why we have to wait a quarter before we can do that. Then we're going to put the new KSK, and we have named it KSK 2017. Even though it doesn't exist yet, it already has a name, KSK 2017. And because of that, we call the current KSK, the one that we generated in 2010, we call that KSK 2010, right? So first we're going to publish, before we're going to use it, we're going to publish the key in the root zone. Then we're going to use that new key and stop using the old key. And eventually we're going to revoke the old key, and then we're going to remove the old key. Right? It's all kind of atomic operations, but they will last a very long time. And there's a good reason for that, and I will get into that in a second. So here are the actual dates. We've already published the plans, July 22nd, for you to see, for you to have a look at. October 27th, it's a very significant date, even though nothing really operationally in the root zone happens, but the new key will be generated on October 27th. And then in February, which is essentially the next ceremony, we're going to put this key also in the other facility, right? Like I said before, we need 2 ceremonies for this, so we're going to do it then. Then we're going to have some DNS key set changes in the root zone. The first one is we're going to add the KSK 2017, right, on July the 11th, 2017. Now, even though the key set changes, and we might have a slightly bigger, and we will have a slightly bigger response, you might see some fallout from that if configurations will stop second fragments, if the package is fragmented, etc. IPv6 might have some difficulty coping with this because the response size of a DNS message will be larger than what IPv6 can handle. But in that case, it should fall back to TCP. All right, so we don't actually think, no, let me just say this differently. We hope, right, and very good reasons to think that things will be fine, right? But this, in terms of DNSSEC, is not yet significant. What is really significant is that on October the 11th, next year, and please put this date in your agenda, right? October the 11th next year, we're going to stop using the old key, and we're going to start using the new key. Now, if you don't have any automated processes, right, to manage that current KSK, and there's an RC about this, RC 5011, if you don't have that automation set, right, on October 11th, things will fail. So what you need to do before October 11th is add that new KSK to your validator, so it can cope with the change on October the 11th. If not, things will fail. So, but since we're still in 2016, not in 2017, you now have all the time, right, to automate things. All the modern software, and that is bind, this unbound, not, power DNS recursor, they can all validate, right? And most, if not yet all, come with tools to help you facilitate this stuff automatically. So this is a hardly readable slide. This is basically the plan from left to right. You have a timeline. You can basically see all the vertical columns as what a key set will look like. I'm going to skip over this. If you're interested in this, have a look at the slide itself online. Systems test plan. One of the plans, this is the second plan that we talked about. We need to test internally if everything works, right? So we're going to generate in our copy of the, an exact copy of the real system. We're going to check if we can actually generate new keys, right? When we talk to VeriSign, or when VeriSign talks to us, right, it's basically all completely automated. They will generate a key signing request, and we will generate a signed key response. So they can publish the signatures over the ZSK, etc., etc. All of this stuff is automated. We need to test it with the new keys as well. Also, trust anchor publication. The new trust anchors will be listed on websites as an XML file. The tools that are currently being built or is already available for some of the implementation. I'm looking at Ben over there. I think Unbound has tools available for this. They already do the right thing. But please have a look at your configuration if you're not sure if it already does things automatically. Monitoring plan. This is specifically what I'm involved in. ICANN runs LRoot. ISI, the Information Sciences Institute, runs BRoot. And we have access to traffic, right, going to the root servers. And we are going to monitor for changes in frequencies of DNS key requests. As with anything, if, for instance, your browser fails to do a request, it will get aggressive. It will try it again and again and again, right, if you want to go to some name. or some website. The same is true for anything in DNS. If you want to query for a DNS key set and you don't get a response, you will try again, right? You might try different root servers, but you will try again and again. So that means that the frequency will go up. Now, if we see the frequency go up, right, we need to know basically from what group of resolvers it comes from. If it's just one organization, right, then we're not going to stop the entire process for just one organization. But if a significant amount, and significant is a little bit vague right now, but if a significant amount of AS numbers show problems due to us rolling the key, we need to know that, and we can monitor for that. We also have means of ad hoc reporting that will come in the end, at the last slide, where you can actually report problems with whatever we're doing. External test plan. This is how and where you can hook up your test systems to our test systems. We basically have, it's basically the exact same system as we're going to use, but then with an accelerated clock. We call that tootservice.net instead of rootservice.net. And the other one is from Google, from Warren Kumari, and it's called keyroll.systems. So if you go there, you can see this automated stuff running much faster than we are currently doing it. Backout plan, when things go wrong. So what we need to do is, if we know that things will go wrong in the future, if we already know this, but we're in the middle of one of these phases, we need to stay in this phase. We can't go to the next phase. And with phases, I mean, remember that I said add the KSK 2017 and then use the KSK 2017 and stop using the old key, and revoke and then delete, right? All of those happen in periods of 3 months, right? Those are phases. So if we know that things will go wrong, we need to do what we're doing right now also in the next phase. So to the next quarter. Not go to the next phase, but keep on doing what we're doing right now. Or, if at the moment we change stuff, things will go bad, we need to be able to go back to the previous phase. Now, all of these things need signatures to be generated and a certain configuration of keys. And all of these signatures will be generated during a key ceremony. And we do this during the key ceremony, so we already have all of the fallback scenarios ready in case we need to fall back. And yes, we do that at the key ceremony because we actually are using the proper keys to generate this stuff. Again, we don't want to do this ad hoc. So what you need to know is, am I managing my trust anchors correctly, right? Go to your bind configuration or your unbound or not or power DNS and see if stuff is happening automatically, right? Look at your bind documentation and your unbound documentation and see if this stuff has happened automatically. Even when it does happen automatically, make sure that that the daemon that runs the name server, the owner that runs the name server, the username that runs the name server, is also able to write the key or overwrite the key on that disk. Again, keep an eye on the dates. I will show you the dates in a minute again. These are the dates again. If you're not doing any DNSSEC right now, maybe this is a good time to look at it, because a lot of people will be looking at current validation, right? A lot of people who already do validation will either make changes or will be assured that everything is going well. But this is the time to get involved. This is the time to basically make sure that validation happens. And if, for instance, you're a large ISP, and Comcast is already doing this, Google is already doing this. If you're a large ISP and you don't do validation, right, your users will have no option to validate that, for instance, their DANE records are correct. So please switch on validation if you're not already doing so. But if you do it, make sure you have automated trust anchor rollover. For more information, you can join the KSK Rollover mailing list. You can follow us on Twitter. We have a hashtag specifically for the key roll, which is #keyroll. There's a web page that I already mentioned. You can there's more information here. These are specific ICANN channels. I also brought a few business cards. There are a few telephone numbers on these business cards. Don't call them. right? Send me email. If you want to call them, my personal mobile number is on here. Feel free to call that. We can have a beer. That's all fine. But any questions related with DNSSEC, there are a few DNSSEC experts here. If you want to know what ICANN is doing with regards to DNSSEC, come up to me. I'm here during lunch for the rest of the day, etc., etc. I'm going to leave my cards here on the desk. I will keep like 4 for myself, so in case someone wants them later. I will put them here, but please have a look at the key rollover stuff we're going to do next year. And if you're not doing validation right now, have a look at switching it on. Thank you.